For centuries, one star has captivated our imagination. A crimson jewel hanging on the shoulder of Orion, a star so massive, so luminous that entire civilizations wove stories about its fiery glow. Betelgeuse. In late 2019, it did something shocking. Almost overnight, one of the brightest stars in the night sky began to fade. Its light dimmed by more than 60%. For weeks, astronomers around the globe braced for history, a star about to die in the most spectacular way possible. This supernova explosion would outshine the full moon and cast shadows at midnight. But Betelgeuse didn't explode. It brightened again. And the world moved on. Yet hidden in that fading light was something astronomers had overlooked, a clue that had been waiting for over 100 years. A secret companion, locked in a dangerous orbit around Betelgeuse. And now, with the help of one of the most powerful telescopes on Earth, scientists have finally seen it. This discovery doesn't just explain Betelgeuse's mysterious dimming. It could change everything we know about how massive stars live and die. What NASA, the Gemini Observatory, and astronomers worldwide uncovered may rewrite the story of Betelgeuse and hint at dangers far closer to home than we ever imagined. Before we dive into this cosmic mystery, make sure you subscribe to the channel. We're building a community that uncovers the hidden stories of the universe, and you don't want to miss what comes next. Betelgeuse has always been more than just a star. It's a landmark in the night sky, part of Orion, one of the most recognizable constellations known to humanity. For thousands of years, cultures from Mesopotamia to ancient Egypt saw Betelgeuse as a symbol, the blazing shoulder of the celestial hunter. But to modern astronomers, Betelgeuse is something far more profound. It's a red supergiant, a dying star that has expanded to nearly 900 times the radius of our Sun. If you placed it in the center of our solar system, its outer edges would stretch past the orbit of Jupiter. Its sheer size, its unstable brightness, and its inevitable fate make it one of the most studied stars in the galaxy. That's why the Great Dimming of 2019 sent shockwaves across astronomy. NASA turned the Hubble Space Telescope toward Betelgeuse. Observatories from Chile to Hawaii tracked its light curves. The public speculated wildly, was this the prelude to a supernova? The answer, at least at the time, was no. Researchers eventually concluded that Betelgeuse had coughed out a vast cloud of gas. That gas cooled, condensed into dust, and drifted in front of the star, temporarily blocking its light. By early 2020, Betelgeuse brightened again, easing fears of an imminent explosion. But the event had done something important. It compelled astronomers to re-examine decades of previously puzzling data. Betelgeuse didn't just pulse in one steady rhythm. It seemed to have overlapping cycles, short beats of about 400 days, and a longer, slower heartbeat that stretched across 6 years. The dimming had pulled back the curtain on something astronomers had long suspected. There was more to Betelgeuse's story than a simple dying star, and what they found next would confirm a century-old mystery. By December 2019, Betelgeuse had already faded to just 35% of its normal brightness. Astronomers compared images taken just months earlier. One of the brightest red stars in the sky had dimmed so much, some wondered if it would disappear entirely. NASA's Hubble detected hot material blasting off from the star's surface. A giant blob of plasma had been ejected into space, larger than the orbit of Earth itself. When that material cooled, it became dust, and that dust veiled Betelgeuse from our view. It was dramatic, but it didn't explain everything. Why did Betelgeuse's brightness vary so wildly even before the Great Dimming? Why did it pulse with irregular cycles? The answers lay in its motion. For decades, astronomers had measured Betelgeuse's radial velocity, the speed at which it moved toward or away from Earth. Think of a car driving straight toward a camera, then pulling away. The pitch of the sound shifts, the Doppler effect. Stars do the same with light. Moving toward us shifts their light bluer. Moving away shifts it redder. When astronomers analyzed a century of data, they noticed something remarkable. Betelgeuse's radial velocity wasn't random. It changed in a smooth, repeating pattern every 2,100 days, almost 6 years. That kind of wobble usually means one thing: gravity. A hidden companion tugging on the star, pulling it back and forth in a cosmic dance. The idea wasn't new. As far back as the early 1900s, some astronomers proposed that Betelgeuse might be part of a binary system, but no telescope, not even Hubble, had ever seen this mysterious companion. The star was simply too faint, too close to Betelgeuse's blinding glare to be detected. Still, the evidence was mounting. The 6-year cycle in both brightness and radial velocity was too perfect to be a coincidence. Something was there, something orbiting. The breakthrough finally came on December 9, 2024. Using the Gemini North Telescope in Hawaii, astronomers trained a specialized instrument called Allopeck on Betelgeuse. Allopeck is no ordinary camera. It's designed to capture images at incredible speed, freezing out the distortions caused by Earth's atmosphere. That night, it revealed something no one had ever seen before. Just 0.05 arc seconds from Betelgeuse's fiery surface, a separation equivalent to seeing a human hair from 10 kilometers away, a faint point of light appeared. Exactly where orbital models predicted it would be. They had found it, the hidden companion. Astronomers gave it a name, Siwara, from the Arabic word meaning her bracelet. A fitting title, since Betelgeuse itself comes from the Arabic for the hand of Orion. Siwara was faint, 6 magnitudes dimmer than Betelgeuse, but real. Likely a young star, 1 to 1.5 times the mass of our Sun. While Betelgeuse is racing toward death, swollen into a red supergiant, Siwara is only beginning its long life as a stable star. This discovery is more than a curious detail. It solves one of Betelgeuse's greatest mysteries: its strange 6-year cycles. They weren't random, they were gravitational. For the first time, we know Betelgeuse is not alone. It's a binary system, a cosmic pairing that has been hiding in plain sight. But the story doesn't end with discovery. In fact, it gets darker. Because Siwara's orbit is not safe. Betelgeuse's outer atmosphere extends far beyond its visible surface, a vast and chaotic region of gas and dust. Siwara, on its close orbit, may already be plowing through this unstable envelope, and that is dangerous. Gravitational drag is slowing it down. Slowly, relentlessly, Siwara is being pulled inward. Astronomers estimate that within just 10,000 years, the blink of an eye in cosmic time, Siwara will spiral into Betelgeuse. The two stars will merge, and that merger could trigger disaster. Instead of a gradual collapse into a supernova, the violent collision could spark an earlier, more unpredictable explosion. A stellar death that would light up Earth's skies like nothing in recorded history. If Betelgeuse goes supernova, it won't destroy Earth. It's too far away for that. But it would dominate the night sky for months, maybe years. It would be visible in broad daylight, and it would remind humanity of just how fragile our place in the cosmos really is. That's why space agencies across the globe, NASA, ESA, Japan, China, are now keeping close watch on Betelgeuse. If it explodes, it will be a once-in-civilization event. A natural wonder our species has never seen. And if you want to see what astronomers uncover next, make sure you subscribe, because the secrets hidden in our skies are only just beginning to reveal themselves. So what comes next? The James Webb Space Telescope is already watching Betelgeuse, analyzing its dust clouds and mapping its atmosphere in unprecedented detail. The Vera Rubin Observatory, set to begin full operation soon, will scan the night sky every few nights, capturing data on millions of stars, including Betelgeuse, and searching for other hidden companions. The discovery of Siwara raises a bigger question. How many other red supergiants are hiding secret partners? Stars like Antares and Scorpius show similar unexplained cycles. Could they too be binaries, shaping their lives and deaths in ways we never realized? For astrophysicists, this changes the models of how supernovae work. Binary systems behave differently from single stars. Their explosions may spread heavier elements, oxygen, carbon, iron, more unevenly into space. These are the elements that eventually form planets, oceans, and life itself. So when we study Betelgeuse, we're not just studying a dying star, we're studying the origins of everything we are. And here's the haunting what if. What if Betelgeuse exploded tomorrow? Astronomers say it would be as bright as the full moon, casting shadows at night. We'd see it in daylight, a second sun blazing in Orion's shoulder. Entire generations would grow up with a sky forever changed. And humanity, for once, would be united under a reminder: the universe is alive, evolving, and vastly beyond our control. While the world stared at Betelgeuse's fading light in 2019, a faint spark appeared beside it. A hidden companion star, circling in silence for millions of years. One star racing toward death, another is just beginning life, bound together in a cosmic dance of fate. And one day, that dance will end in fire. Betelgeuse will explode. Siwara may be swallowed. The skies above Earth will blaze with light not seen since humanity first looked up. The real question isn't whether it will happen, it's when. And when that day comes, will we be ready to witness history written across the sky? If you enjoyed this story, subscribe and join us as we continue to explore the hidden universe, one mystery at a time.